Alright, for this video we're going to use the MCI 210 module, put it in an M700 drive, and use it as a Modbus TCP IP master to control this Phoenix contact I/O block. And we're going to use the standard CT Modbus library that comes with Machine Control Studio. So this is not my custom libraries, this is one just exactly the way it looks right out of the box. So today I've decided to use this Phoenix Contact I/O block, and the nice thing about this particular Phoenix Contact I/O is this particular tab here. When you click on it, it breaks down all of the slices you have in your I/O. So you can see I have 1, 2, 3, 4 slices of I/O, and it gives you the part number for each of the slices, it gives you a description of each of the slices, but most importantly it gives you the Modbus register for each of the slices. So you can see that if I needed to write to this slice of I/O, which is of course 4 digital outputs, I would look at this register as being my destination target. You also might notice that the outputs are all in the 9,000 range and all of the inputs are in the 8,000 range. That is the way this particular bus coupler is set up. Other Phoenix bus couplers are not set up this way, but this one's set up that way. To keep this video short, I have pre-made a little project that you can download in the bottom of the link. So as you can see, there's not a lot here. There's really just 4 rungs of logic. I got one ladder rung that's calling a sub-action called setup network. I got one rung that sets it up to do a read, one rung that sets it up to do a write, and one rung that does basically all the work. And this is really the key block. And you might ask, why do I have these positive edge? Well, later on when we go online, I'm actually going to manipulate the program manually, so I don't really want these blocks running. But I just wanted to show you how you would do it, right? But before you can use this block, you have to technically import it into your projects. To do that, you go into Library Manager, you'd come up here to the Add Library, and you'd look for the following 2 libraries. One is CT Modbus Client, and the other one is CT Networking. Technically speaking, the CT network is not required, but it allows us to change a string into a number. And not any weird string, a particular string, an IP address string. So if I wanted a 192.168.151, right, I could put that in as a string. It would get converted into a number that would then get passed to this client. Now this library here, it doesn't know how to use strings, so that's why I use this. Technically speaking, you could just do the math yourself and put it in here and be done. So let's go back to here and let's talk about how this actually works. Well, this block has 4 inputs, and most of the time you're not going to use blocking. It's going to be false, because most of the time you're going to put this in a clock task. Okay? These 2 inputs are pointers to some key data that's up here, and I'll talk about that in a little bit. The one thing you need to know here is this execute. The execute is actually rising edge triggered. So anytime you want to do a new write or a new read, you got to go from a false condition to a true condition. The block will start to execute, and when it's done, you'll get one of 2 answers. You'll either get a done or an error. If you get an error, you will also get an error code. The error code is nice in that when you look at it, it will actually give you a description in Word. Address not reachable, or invalid holding address, or data rejected, or whatever. Some sort of code that technically is all called out in the Modbus world. To set this up, you really just need these 5 pieces of data. Of course, this first one here is just declaring this block. The second 2 are setting up the structures. Now in the CT Modbus library, there's these 2 structures. One's called server, and one's called channel. The server really just holds all the important data to connect to the device, like the IP address, the port, how long before timing out, that kind of data. The channel structure is used to hold all of the data that is important from the point of reading and writing messages. And it also holds a pointer to both these two arrays. Now, here you can see I have two arrays, one's called send and one's called read. And I'm pretty sure you can guess that the send is used to send data to the I/O block and the read is used to read from the I/O block. And you're entirely correct, except for there's one extra thing the read is actually used for. When you go to send stuff to the I/O block, the I/O block actually sends data back to you, like, was it good, things like that. That kind of information actually ends up showing back up on this read. So this read is technically dual purposed. If you wanted, you could create a second set of reads, one for debug data. Let's set this up. So we're going to click here, and I'm going to move this over here so we can see the declarations at the same time when we're talking about. So this device 1 connection, that's right here. So this section right here is that data. Okay? So the first thing I do is I set up an IP address. Here's the function code that lives in that library that I'm telling you about, that I like. Okay? So it converts this string into a number that's useful. Here's this number, 502. This is a standard Modbus port that everyone uses. Here's some timeout. So it's all in milliseconds, so 1000 equals 1 second. Now this part here is the unit number. Most devices use a unit number of 1, or they just don't look at it at all. So 1's a pretty safe bet to use if you don't know better. The Phoenix doesn't appear to care what you put here. Now to set up the data structure, that's this part here. That requires all of this data. But I'd like to look at it from 2 points of view. Really, there's a setup, and then there's the stuff we tweak over and over and over again. So right here, what we're doing is we're pointing to what they call the request data, and that's the send data, is what I call it. So this keyword address, it says the address of where this lives in memory space, I want to give it to this guy, okay? And this keyword here called size of, it looks at this and says, well, I can see that it's 0 through 10 of type int, so here's how big that array is, which is pretty handy because if you change this array to say 20 items, right, or technically that's 21 items, you don't have to change anything here. This does it for you, so it's a pretty handy keyword to know. And on these two lines, we're doing the exact same thing, but instead of being the send, it's the read. Alright? Here's the function code. If I move this over, you can see there's function code read. There's a whole bunch of different function codes. These are all standard Modbus function codes. For right now, I'm just going to put it back to read holding register. The read starting address is the first address you want to start reading from. So see this 9006? That actually came from my Phoenix I/O. And so I'm going to actually read this slice right here, 9006. I could technically, though, start from here and have it read, say, 7 pieces of data. I would get 1 piece of data here, a couple pieces of zeros, and then another good piece of data. But for this demonstration, I'm just going to read one at a time. So right now it says 10. If I was to try this, I would get an error. This really needs to be 1. Alright. Very good. Okay. The read block looks just like this part. So I just open the read. You'll notice it's exactly the same stuff as this, except, well, it is exactly the same because I set that to read. Alright. And if I come to the right, it's exactly the same. The only thing that changed is this is now a write. Really, this is the material, this is the data that you're constantly changing. So let's go online and actually see this thing work. So we've started the Modbus master, and so let's say I want to read something. Well, I'm going to open this up so we can watch it. So I need to, let's see, what input is it? Oh, that input. So I turn this on. So it's set up to do a read, and now I'm going to trigger input 4, and you can see there was no error. Okay, and you can see I got a value of 11 right here, only reading 1. So if I put these back to 0, force them back to 0, I do the read again, you'll see it only updated this one. Now if I make this a write, okay, so it's set it up to a write. Let's come back into our send data. I'm going to actually have it send a 4 this time. Close that up, and if I trigger the execution, you're going to see that it put a 4 on this line here. Okay? So what this is saying is I wrote to this register, and this is the data I sent. If the data was bad, you would get something else. So make it a read again. Right. Okay. So like I said, the read is kind of a dual purpose with this library. So I'm going to actually come over here and modify things manually. Right? So I'm going to come over here to the data structure. Okay. And instead of being a holding address, I'm going to actually make this a write single register. Okay. And instead of writing to 9006, I'm going to come over here and write to 9000. Okay, so here we go. Now you didn't see it, but it actually worked. I saw some lights change on my I/O block, and as you can see, there's no error. Now what if I had an error? Well, let's do that. So instead of being 9000, let's try to do a write to 8000. As you can see from the Phoenix I/O block, this is not writable. It's an input only. So we're going to do a write to 8000, and you're going to see that when I trigger it on, it says register address not correct. That's the response back from the Phoenix block. If you like this video, please subscribe or put a comment below.